Hello everyone, this is an Amarnath, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology. It is a second lecture, continuation in the eigenvalues and eigenvectors of a matrix. Subject name linear algebra and calculus. So let us go for the next problem and we will explain how to find eigenvalues, eigenvectors also this time. So last one we have done only eigenvalues we have done, and this time we are going to do eigenvectors of the given 3 by 3 matrix. So it is a given 3 by 3 matrix, right? So we are going to find eigenvalues as well as eigenvectors. Vectors is nothing but solution of the homogeneous equation, right? Now, so let us start. Eigenvalues, like as the previous method explained, I will do the shortcut method so that easily you can answer. We need to write characteristic equation of A is det of A minus lambda I is equal to 0, right? I said how to write det of A minus lambda, take the determinant from the principal diagonal elements, subtract the lambda. So first principal diagonal 5, remaining 2 elements no change. Second row minus 2, second diagonal element 6 minus lambda, 7 minus lambda, 5 minus lambda. From the diagonals we should write minus lambda subtraction. 2 remaining elements no change. 7 minus lambda is equal to 0. Okay na? From the diagonal 5 minus lambda, 6 minus lambda, 7 minus lambda is equal to 0, right? Now expansion. Expansion is, if you feel difficult, I have given a shortcut formula that I will use. Lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. We have explained very clearly what is S1, what is S3, S2, S1, that is trace of the given matrix, that is called sum of the principal diagonal. This 5, 6, 7 sum, that is called trace. 5 plus 6 plus 7, that is equal to 18. So S1 is 18. S2 sum of the cofactors of principal diagonal elements, that directly I am writing since we explained in the last problem. Now leaving the 5 and remaining leftover matrix 6, 2, 2, 7. At the first principal diagonal 5, this leaving this row and leaving this column, remaining elements 6, 2, 2, 7. Next second principal diagonal 6, leaving the second row and the second column, remaining elements 5, 0, then 0, 7. Next third principal diagonal 7, leaving this column and leaving this row, remaining elements determinant 5, minus 2, 6, right, which is a summation determinant. 6, 7 the 42. Determinant we can find 2 by 2 determinant, that is AD minus BC. 6 into 7 42, 42 minus 4 38 plus 5 7 the 35 minus 0 plus 5 6 the 30, 30 minus 4, 30 minus 4 26, right? This is a equation, a summation we need to find, that is 38 plus 42. How much this is? 38 plus 35, 38 plus 35 and 26, 99. Okay, this is 99. So S2 value 99. So here only the student should do carefully. S3. What is the S3? Det of the matrix. So how to find det of the matrix? So here I am writing 5 minus 2, 0, minus 2, 6, 2, 0, 2, 7. We need to find det of this matrix. We know very well, as usual, we expand the first row or second row or second column, but generally we expand first row. Signs we are deciding plus, minus, plus. Okay, that is first one, leaving the row and column. 6 into 7 42, 42 minus 4, that is 38. Next second 5 into first row, 5 into 38, second element minus of minus plus 2, leaving the this row and leaving the column, minus 2 into 7 minus 14, 0 into 2 0, no need to write, last element 0. Okay, 5 into 38, 5 into 38, 5 3 is 150 and 90, 190, minus 2 into 14, 28, 190 minus 30, 160 at 162. This is the S3 value, 162. Okay, now substitute. We got all values S1, S2, S3, substitute S1, S2, S3 in equation 1, which we have assumed the equation of the determinant expansion. Lambda cube minus S1, S1 is right 18, 18 lambda square plus S2 lambda, S2 is 99. Next minus S3, S3 is 162, which is equal to 0. It is a cubic equation we need to solve. Solving here I am giving directly. Students, in the last class we have discussed how to find the roots of the equation. You can use remainder theorem, factorization, synthetic division, or directly we can use the scientific calculator. In the scientific calculator we have one option, equations. Go to equations option, equation options you can take, and third degree polynomial you have to take, third degree polynomial, and you have to enter the coefficients. What are the coefficient? Lambda cube coefficient 1, lambda square coefficient minus 18, next lambda coefficient 99, and a constant minus 162. These 4 values you have to enter. Okay, now if you enter directly, calculator will give the required roots. Otherwise, like as the previous problem, you can do the factorization. Now solving, what we are getting, solution lambda is equal to, that is here directly I am writing 3, 6, 9 are the roots for the above equation. Then we need to check whether it is correct or not. How to check? I said in the previous slide, that is the sum of eigenvalues is equal to trace. So already we have the trace. What is the trace? That is first one 18, sum of the diagonal elements 5 plus 6 plus 7, that is 18. Now sum of eigenvalues, sum of eigenvalues, how much? That also should be equal to 18. See, check it, 3 plus 6 plus 9, which is equal to 18. Both are equal, 18. So trace must be equal to sum of the eigenvalues. That is a checkpoint to verify our eigenvalues are correct or not, right? So we got, these are the required eigenvalues or characteristic values. Yes, now we got eigenvalues. Now for corresponding each eigenvalue, we need to find one solution or one eigenvector. For lambda 3 is equal to 1 eigenvector, for lambda is equal to 6 1 eigenvector, for lambda is equal to 9 one corresponding eigenvector we need to find. Now we discuss how to find the eigenvectors in the next slide, right? Remember the students, these 3 eigenvalues are distinct eigenvalues, because distinct eigenvalues are the how to find eigenvectors. Repeated eigenvalues, suppose some problem we make it like this, 1 1, the previous problem we got 1 1 5, here repeated eigenvalues 1 comma 1, then a little bit change in the procedure finding eigenvectors. So both we discuss. Now here we got distinct eigenvalues, that we discuss how to find the eigenvectors corresponding to each one eigenvalue. Now first one, for lambda is equal to 3, so corresponding eigenvector we need to find. So we discuss the formula. What is the eigenvector formula? A minus lambda I into x is equal to 0. This is the formula to find eigenvector. So here in this case we are taking, put lambda is equal to 3, right? Now A minus 3i into x is equal to 0. A minus 3 means we have to subtract the 3 number from the principal diagonal elements of the given matrix A. So here what is the matrix we have here? A is equal to, we have 5 minus 2 0 minus 2 6 2 0 2 7. This is a previous problem we have taken the matrix S5 minus 2 0 minus 2 6 2 0 2 7, right. 5 minus 2 0 minus 2 6 7 0 2 7. A minus 3i means these 3 should be subtracted from diagonal. So from 5 6 7 at a 5 minus 3 6 minus 3 7 minus 3. Remaining elements won't get changed because it is identity matrix is contain diagonal only 1 1, remaining elements are 0. So subtracting 0 no change, but these 3 should be subtracted from diagonal. So I am writing A minus 3 I am writing. So subtract 3 from diagonal element, 5 minus 3 2 minus 2 0. Next second element minus 2 no change. Second diagonal element 6, subtract 3, 6 minus 3 3, remaining elements no change, 0 2. Third diagonal element 7, 7 minus 3 4 into this is A minus 3i matrix into x, etc. This we are finding eigenvector, we are calling x as eigenvector, that is x1 x2 x3, which is equal to 0 0 0 0. Since it is a 3 by 3 matrix, so we need to write 3 unknowns x1 x2 x3 that we need to find. 0 0 0 is a column vector. Now here how to solve this, we need to find eigenvalues, that is a x1 x2 x3 eigenvector corresponding. So multiply row versus column, we know how to multiply the two matrices. So here first element, here first element, I am multiplying first row with the x1 x2 x3, minus 2 into x1 minus 2 x1 minus 2 into x2 minus 2 x2 plus 0 into x3 0 x3, let us write 0 also as it is, okay, it will be easy for us. Next second row multiply with x1 x2 x3 corresponding element, here first element, here first element, minus 2 x1 plus here second element 3 x2, row versus column, plus 2 into x3 2 x3. So one more equation, that's we can take, or these two equations also sufficient to find x1 x2 x3. So here we can solve, actually this is a homogeneous system, we have to use echelon form, we need to reduce to echelon form, that is the original method. Here also I am doing one shortcut method to solve these two equations. So whenever this eigenvalue is not repeated, 3 is not repeated on a single one, so we can apply this shortcut method where we study in the intermediate level solving the equations with crisscross method. So that I am telling how to find. Now first we take x2 coefficient minus 2, right, and x3 coefficient 0, right, in this manner, x1 coefficient minus 2. Next coming to a second equation, x2 coefficient 3, x3 coefficient 2 and x1 coefficient minus 2, and repeat the first one, here minus 2, again repeat here minus 2, 3 again 3, this one is x1, this one is x2, this one is x3, right, like this. We need to find x1 x2 x3. Now first this x1 is related to this one, these two rows x1, these two rows x2, these two rows x3 values will give. How to find this one? Simply here look at this one, x1 by this is AD minus BC, this into this minus this into this, minus 2 into 2, this time I am writing very clearly, minus, next this into this, 3 into 0, to make you understand I am writing very clearly here. This is x1 over, next coming to x2 by, again these two rows determinants, 0 into minus 2, 0 into minus 2, minus 2 into minus 2, x3 by, this into this minus this into this, x3, this into this minus this into this, x3, minus 2 into 3, minus 2 into 3, minus, and this into this, minus 2 into minus 2. So since these three are the ratios must be equal to some constant, let us say some k. Now let us simplify, x1 by minus 2 into 2 minus 4, that is a minus 0, x2 by 0 into minus 2 0, minus of minus 4, right, 2 into 4, x3 by minus 2 into 3 minus 6, minus of, that is a minus 4, minus of minus plus 4, minus 2 into minus 2 minus 4 and minus 6. these required equations, minus 6 minus 2 into 3, minus 6 minus 2 into minus 4, and this equation will give required value 2, minus 6 plus 4, that is 2, which is equal to k. This is a repeated one, minus 2, 3. So, minus 4 and plus 4 minus 4, right. X1 by minus 4, X2 by 4, X3 by 4. Let us check once here, minus 2, 0, minus 2, 0, this is a plus 2, right, small mistake here, this repeated one. Look at once again, recheck these values, what is considered, minus 2 into 2, minus 4, 3 into 0, 0, 0 into minus 2, 0, minus 2 into this is a plus 2, 4. This is when you are going up, minus 4, this is a plus. Next, 2 into 3, 6, this is plus 6, 6 minus 4, this is 6 minus 4, 2, 6 minus 4, this is plus 6 minus 4, that is 2. Let us have this one. Since the denominators can be cancelled with 2, we can write in the lowest terms 2 minus 2's, x2 by minus 2, 2 to the 4, 2 to the 4, x3 by 2 ones is equal to k. Now, here we got 3 values, minus 2k, k on cross multiplying. We can cross multiply, x1 is equal to minus 2k, x2 is equal to minus 2k, x3 is equal to k, right. Now, so if you write the first eigenvector, x1 is equal to minus 2k, k. If you take k common, that is a minus 2, 1. So, always k will be not equal to 0. Why? Because if k is 0, this total vector will become 0 vector. Eigenvector must be non-zero eigenvector. So, that is x1 is equal to minus 2, 1. So, this is the first eigenvector for the lambda is equal to 3. Similarly, we can find the eigenvector for 6 and 9. So, here I am giving the for the lambda is equal to 6, directly I am giving second eigenvector, similar procedure, cross method we can find. So, x2 is equal to, we will get 2 minus 1, 2, and x3 is equal to minus 1, 2, 2. So, directly I am giving, this is for lambda is equal to 6, lambda is equal to 3, this is for lambda is equal to 6, lambda is equal to 9. So, these are the eigenvectors corresponding to given eigenvalues 3, 6, 9. So, suppose we are unable to find this shortcut method, we can use the echelon form. How to do the echelon form, that also I will explain for lambda is equal to 3, same I will explain. So, look at this one, how to find now. So, here a minus 3i, or alternate method I am teaching for the finding eigenvector, a minus 3i into x is equal to 0, right. So, a minus 3i we have done previous one, 5 minus 3, 2, minus 2, 0, subtract 3 from given matrix, minus 2, 6 minus 3, 3, 2, 0, 2, next 7 minus 3, 4, x means x1, x2, x3 is equal to 0. So, I am telling alternate method to find eigenvector. In the previous one we have done using two equations cross method, we have done the root. See, in the previous one we have done cross method here to find the root x1, x2, x3. In this slide I am going to explain for same for lambda is equal to 3 using echelon form how to get the root, right. See, minus 2, 2, 5 minus 3, 2, minus 2, 0, minus 2, 6 minus 3, 3, subtract 3 from diagonal elements, 2, 0, 2, 4, right. Now, echelon form means, let us briefly explain the echelon form. Echelon form means any 0 rows are there that should below the non-zero rows, and here 2, 3, 4, let us say one echelon form, 2, 3, 4, 5, 0, 1, 2, 0, 0, 0, 0, minus 1. See, the number of zeros to the first non-zero entry should increase by term row wise. That is called echelon form. So, here 1 zeros, here 3 zeros, here 4 zeros. So, zeros in this pattern 0, 0, 0, 0 before the non-zero entries. The first before the non-zero entries, if the zeros are increasing 1 0, 2 zeros, 3 zeros, 4 0, that we call echelon form. Any zero rows are there should be below the non-zero rows, and the number of zeros before the non-zero entry, first non-zero entry, should increase by the next row. That is called echelon form. Now here, and to reduce the given matrix to echelon form, we have to apply only row operation, and only row transformations. We should not use column operations. Basically, how we will do means using the first top element at first element. So this one diagonal element, we will make below elements 0. Next, we will take the second diagonal element and we will make below element 0. And third diagonal below element 0. That is the echelon form procedure we used to study in the first unit of the LA&C. Right? Here now using the R1, this is R1, this is R2, this is R3. Already R3 element is 0. Using R1, we have to make these two elements 0. So then R2 implies R2 plus R1. Right? And R3 is already 0. You no need to do any change. Now first row 2 minus 2 0, R2 plus R1 minus 2 plus 2 0, 3 minus 2 1, 2 minus 0 2. Right? So third row we are not doing change 0, 2, 4. So x1, x2, x3 we need to find. So you no need to change this x1, x2, x3 0, 0, 0. Now using second diagonal element 1 and R2, using R2 we have to make R3 element 0. So that is R3 implies R3 minus 2 R2. We are using R2 elements. Now first row we are not doing any change, 2 minus 2 0. Second row we are using, so that's why it should not be changed. Next third row R3 minus 2 R1, 0 minus 0 0, 2 minus 2 into 1 2, 2 minus 2 0, 4 minus 2 to the 4, 4 minus 4 0. So it is in echelon form x1, x2, x3 0 0. How can we say it is in echelon form? I have given a condition here 1 0 here, 3 zeros. Number of zeros are increasing when you go to the next row before the first non-zero entry. So it is in echelon form. It is in echelon form. Next, so what is the rank of the matrix? Number of non-zero rows is called rank of the matrix in echelon form. See here 1, 2, 2 non-zero rows, rank is 2. But unknowns, how many unknowns? 3, x1, x2, x3. It is a homogeneous system of equation. Here n less than, here r is 2, n is 3, r is less than n. In this case, we have to select the arbitrary constant. At one row is missing, at one arbitrary constant we are unable to find. That should be taken as the arbitrary constant. For that one, how many should be taken arbitrary constant? We have the rule n minus r formula. N is the number of unknowns 3. R is the rank of the quotient matrix, that is 2. 3 minus 2 1. The 1 should be selected. One arbitrary constant should be selected as arbitrary constant. Let x3 is equal to k be the arbitrary constant. Be the arbitrary constant. Arbitrary constant means we are fixing x3 as some k. K means it can take 1, 2, 3, minus 1, 0, anything, arbitrary value. So we need to find x1 and x2. See, we are multiplying, right? So multiply 2 into x1, 2x1 minus 2 into x2, minus 2x2 plus 0 into x3, 0, right? Second row. So here 0 into x1, 1 into x2 plus 2 into x3 is equal to 0. But x3 already we had taken as k. So x2 plus 2k is equal to 0. It implies x2 is equal to minus 2k. Now we got x2. Substituting x2 we get x1. Substituting the first equation 2x1 minus 2 into x2 value minus 2k, x2 value minus 2k is equal to 0. Here I am substituting x2 value to get x1 value. So simplifying 2x1 is equal to minus 4k, that is plus 4k, minus of minus plus 4k, take to other side minus 4k. So cancelling with 2, x1 is equal to minus 2k. So we got three values, x1 is equal to minus 2k, x2 value is minus 2k, x3 value k. So eigenvector, how will you write eigenvector? x1, x2, x3, right? Now x1 we got minus 2k, x2 minus 2k, x3 k. So taking k common, that is minus 2, 1. So where k not equal to 0, this will be the eigenvector. So that is first eigenvector that we are getting, x1 is equal to minus 2, 1. So we can check it with the previous method that we have done. See, minus 2, see lambda is equal to 3, we got same minus 2, 1, same eigenvector we got. So we can use this shortcut method or the original method for the homogeneous system changing into echelon form. This is nothing but echelon form method. So the students, those who are familiar with echelon form, they can use this one. Suppose they don't know echelon form, they can use the previous shortcut method. So in this process we can find the eigenvalues and eigenvectors. Here I have given only for lambda is equal to 3. Similarly we can for 6 and 9. Here I have mentioned the values. For lambda is equal to 6, this is the eigenvector, and for lambda is equal to 9, this is the eigenvector. So you can do this one very easily. This eigenvector can be done in any one of the method. So here I have given the alternate methods for eigenvalues and alternate method for eigenvectors. Students are depends on their skill, they can follow the any one of the method. So here this is the methods to find out the problems. Here I am giving some problems for practice for the student. That is 2 problems here I am mentioning. Find the eigenvalues and eigenvectors of the, it is also one 3 by 3 matrix and it is also one 3 by 3 matrix. So here I am for the reference, I am giving the eigenvalues also. For the first problem, eigenvalues are 0, 3, 15. Second problem, eigenvalues are 0, 0, 3. Student can solve and they can check the answers. So here what we have done in this session, that is we discussed about how to find eigenvalues of the eigenvectors of a matrix, 3 by 3 matrix, and alternate methods also we have done. In the next video lecture, I am going to discuss about the applications of eigenvalues and eigenvectors, and suppose if eigenvalues are repeated, suppose lambda is equal to 3, 3, 5, then how to find eigenvectors. That is a little bit different compared to this one. That also I will explain the next video lecture, applications and all these things. So with this one I am closing my video lecture. So thank you